Today's lesson, we're going to talk about angle, arc lengths, and circular motions. So we're going to learn there is more than one way of measuring the angle. One that we already know, which is the degree. And one circle is going to be 360 degrees, and the other one is going to be radians, 2 pi. So if I give you some example with that, if we have one circle, that going around that one circle, we know that's 360 degrees. Radians, it's going to be 2 pi. We know this is 90 degrees, right? Straight up. That's going to be pi over 2. This is 180 degrees, which is straight line. That's going to be pi. And this is 270, which is going to be 3 pi over 2. And we're going to use the radians a lot in this class. So we need to get familiar with it. The first thing we need to do is knowing how to convert from degree to radians. Degree to radians, you're going to multiply degree times pi over 180. Radians to degree, we're going to multiply radians times 180 over pi. Remember the positive angle, if this is the initial side, positive angles start from going up, which is counterclockwise, right? So this is going to be positive angle. If you go this direction, it will be negative angle, right? Going this direction's positive angle. And make sure, we're going to do example of finding coterminal angle, so make sure you understand the definitions. Let's see, and we're going to go over how to find arc lengths, and there is a formula to do that. One more thing, we're going to use the theta as the angle. So if this is the angle that we wanted to represent, we're going to use the theta for it. And when we're using the formula for finding arc lengths and area of the sector, this theta must be measurement in the radians, not the degree, right? First example we have is changing degree to radians. So 45 degrees, we wanted to change to radians, so multiply. Radians, we know that it's going to deal with the pi, right? So we wanted to multiply pi and need to get rid of degree. That's why we multiply degree on denominator. This way, we know 45 goes into 184 times, gives you pi over 4 radians. Same thing, if we have 150 degrees, multiply by pi over 180 degrees, so that degree will cancel out. 3 goes into 15, 5, 6, which gives you 5 pi over 6 radians. Even the negative angle degree is the same, multiply by pi over 180. So this gives you, let's see, 90 goes in twice, and 3 times, carry over 1 negative, so it gives you 3 pi over 2. So again, you multiply pi over 180 degrees to convert from degree to radians. Example 2, the other way around, doing radians to degree. So this one, pi over 9, we're going to now multiply because we wanted to get rid of pi if it's possible. So pi on denominator and 180 on the numerator. Gives you pi and pi cancel out. 9 goes into 18 two times and you had a 0 remain, so it will be 20 degrees. Same thing, right? So 11 pi over 6, what are we multiplying? 180 degree over pi. So pi will be cancel out. And then when we reduce this, (11 times 30), so it will be 330 degrees. What about when you don't have pi, right? What happened? So this is going to be just 3 radians, no pi. Same thing, we still multiply by 180 over pi. So this gives you 540 degree divided by pi. And when you plug in that into the calculator or divide by, use the long division to do dividing by 3.14 because that's what pi is, you're going to get close to 171.89 degree. Example 3 is asking, draw each angle standard form. We are familiar with degree, but not the radian. That's what they want you to exercise on it. 5 pi over 6, 5 pi over 6. This is before pi, right? If we do pi minus pi over 6, we will get 5 pi over 6. So what do we know from that? This is pi, right? And this is 2 pi. So we'll be before pi. How much before? Pi over 6 before pi. So if this is pi over 6, your standard form, this is going to be 5 pi over 6. This is how you're going to know which quadrant your angle is going to be. If your radians is, when you convert it, it's going to be before pi, that should be here. If before pi over 9, that should be the first quadrant, right? Let's look at the next one. What about if you have 8 pi over 3? If numerator is way bigger, what I like to do is converting into the mixed number, mixed fractions. And this gives you 2 pi over 3. This means you have the whole circle, right? So if this is, so this 2 right here is going to be 2 pi. You have a whole circle. And going 2 pi over 3 more. I need to know if 2 pi over 3 is smaller than or larger than pi over 2. Pi over 2. It is smaller than pi. Because it's bigger than pi over 2, it should be on a second quadrant. So from after one circle, go a little further to get 2 pi over 3 more. Okay. And that's going to be 2 pi over 2 pi over 3, right? Or 8 pi over 3. So after one rotations, then go 2 pi over 3 more. So I guess this angle right here should be pi over 3. When we have a negative angle, go backward. Remember, this is positive angle, and going this direction will be negative angle. So let's get rid of it. Negative angle goes clockwise. 135 degrees should be somewhere here. So this right here is going to be negative 135 degrees. Example 4 is asking you to find the coterminal angle. Coterminal angle, that's within one circle, right? So if I draw the first negative 120 degree, so it'll be something like that. This is going to be negative 120 degree. Your coterminal angle is going to be, because it's within the 360 degree, it could be from the positive angle, right? This right here. How do we find that? It's going to be 300 minus 120 degree, which is 240 degree. If we didn't have these restrictions, we could also say it will be from not just negative 120 degree, but after one circle, going back. So negative 120 minus 360, that's going to be negative 480. That's also coterminal angle. But we're not using that. Why? Because they're asked to find the coterminal angle that's within 360 degree or 2 pi, right? Okay, so then let's try the B. Let's figure out which quadrant your line is going to be. So 17 pi over 6, change it to mixed number, you get 2, 5 pi over 6. This means after one rotations. So you go one rotations, one circle, and then you go 5 pi over 6 more. And I need to know what 5 pi over 6 is. This is before pi, right? Your pi is equals to 6 pi over 6. And 1 over 6 shorter, 5 pi over 6 is. So it will be somewhere here. And you will say this is going to be 5 pi over 6. Or 17 pi over 6. But if you're looking for coterminal, you could say just this angle right here, right? What's that angle? That's 5 pi over 6. So coterminal means the same measurement, but different rotations. Example 5 is asked to find the arc length. We have formula for arc length, and that is arc length equals to radius times theta. And when we're looking at the first problem, it says the radius is 3 inches and theta, which is central angle, is pi over 3. And this is already radians, so we can use as it is. When we plug into the formula, we will have 3 times pi over 3, which is going to be pi inches. And that's going to be the arc length of that given problems. What about B? Its 8 radians is 7 inches and central angle is 45. So the first thing I need to do, well, let's just write down what I have. R is 7, theta had to be in radians form, but you have a degree given, so let's convert that to radians. And it gives you pi over 4. Once is the radians form, then let's replace it into the formula. It gives you 7 pi over 4 inches. of the arc lengths on that problems. The next one is finding a sector, area of the sector. Remember the formula of area of the sector? And here you need to use the radians too. So let's convert the degree. That's going to give you 30 degree times pi over 180 degree, which you get pi over 6. Once we get the right amounts, let's replace it into the formula. Your radius is 2, and your theta is pi over 6. This is 1/2 times 4 times pi over 6. Let's reduce the number. Gives you pi over 3. Make sure to understand or go over all those instructions. It's a round the answer to the 2 decimal place. So let's do the dividing. 3.14 divided by 3, you get 1.05, and this is the area, so it will be square feet. Will be the area of the given sector.